All right, so remember that we said that their whole idea of the cardiovascular system was to get blood down to the tissues, to make sure the tissues are perfused. And so we've talked about now how we control cardiac output, the one variable. So we know that cardiac output equals heart rate times stroke volume. And now we know all there is to know about speeding the heart up and slowing it down, and basically increasing the amount of blood that's pumped with each contraction, the stroke volume. The other variable that's controlled in order to regulate the heart is, or regulate the cardiovascular system, is blood pressure. And remember, that's mainly controlled by peripheral resistance. The three things that affect peripheral resistance are what? Turbulence, viscosity, and basically that's the changing of diameter. So in a moment to moment, we can't change turbulence. We can't change viscosity. Thank you, the thick one. Viscosity, and we can't change the length of our blood vessels. You know, as we gain weight, we make more. We make it longer, but you can't change that moment to moment. So what basically the body does is, in order to control blood pressure, it changes the diameter of the vessels, particularly the arterioles. And just like heart rate, stroke volume can be controlled by the nervous system and the endocrine system, so can blood pressure. In addition to that, in every little tissue area, you have local control of the blood pressure in that tissue. So not only do you have systemic blood pressure control, you have the blood flow, the blood pressure in that tissue, in that little capillary bed, is controlled locally. Remember we talked about the precapillary sphincters? If the tissue doesn't need, if it's got plenty of oxygen, plenty of nutrients, that blood's going to be shunted somewhere else. So when you're thinking about controlling blood pressure, you have to think, am I talking systemically, or am I talking just in this one little area of the body? For instance, the skin on your butt. It's not doing a whole lot right now. And so you don't need as much blood flowing to those tissues as you do, say, to your hand who's moving the pen. Make sense? And so the blood pressure, the blood pressure in your arm might be a little bit greater than the blood pressure into your butt.
So which one's systemic?
Well, both of those would be local. Okay. The blood pressure into your hand versus the blood pressure into your butt. But if I measured your blood pressure over here, it would be, that's your systemic blood pressure.
Is that good?
Overall. Okay. And so, but this might be, the pressure here might be a little different than the pressure here. Does that make sense? Because the cells, the hand muscles, they would be using up oxygen. They would be producing carbon dioxide. They would be using up glucose. And so that would create chemical changes in the tissue fluid, the interstitial fluid. And those chemical changes would make vessels dilate so more blood would flow into that area. Does that make sense? So, if we think about local control, all the little capillary beds all over your body, these are the things that relax those precapillary sphincters, that let blood flow through those capillaries. Low oxygen, high carbon dioxide, low pH. Now here's what you have to remember. If CO2 goes up, pH goes down. Why is that? Remember that water plus carbon dioxide. And of course your cells, if your cells are metabolically active, they're breaking down glucose, they're producing carbon dioxide. This is carbonic acid, which falls apart to produce hydrogen ions and bicarbonate ions. So if this increases, this increases. If that increases, pH decreases. And under these conditions, low O2, high CO2, low pH, any of this other stuff we'll talk about in a second, any of these can cause those precapillary sphincters to dilate. Any of these, yeah. These three things usually come together. They usually you have all three of these conditions at the same time. Anyways, when these precapillary sphincters relax, blood is delivered, and so the cells that are in here, they can, the CO2 can be taken away and oxygen can be dropped off. Now, nitric oxide, not nitrous oxide, that's what the dentist gives you. Viagra works by increasing nitric oxide. And so it increases blood flow, basically in a lot of places, but increased blood flow to the penis causes the erection. High levels of hydrogen ions or potassium ions. Now hydrogen ions, of course, anytime you get this, you're going to get this. What about potassium? When your cells start to be in stress, when your cells become stressed, potassium leaks out. Remember that cells have a high level of potassium on the inside, right? Good old sodium-potassium bond. And so when those cells get stressed, potassium leaks out. So again, that's an indication that the cells need more nutrients. They need more oxygen. They're getting stressed. Your immune system can release inflammatory chemicals. So anytime there's inflammation, one of the things that happens is increased blood flow to that area. When you think about getting a paper cut, you know, initially you get the paper cut and like, oh crap, that's going to hurt in about 30 minutes, right? Because what happens is it begins to turn red, it begins to swell. That's because of the increased blood flow to that area. And then elevated temperature will do the same thing. Dilate the vessels. More blood. Think about it. You turn red when you get hot because you're trying to radiate that heat. The vessels are dilated. The capillary, precapillary sphincters have dilated. More blood is flowing to your skin. Make sense? And so all of that is going on locally at every little capillary bed, regardless of what your systemic blood pressure is. Now, vasoconstrictors, most commonly, if you cut a blood vessel, one of the first things that happens is those smooth muscles tend to contract to limit blood flow. When we get to blood and clotting, we'll talk a little bit more about that. But when you damage a blood vessel, a lot of these chemicals, these things, prostaglandins, thromboxanes, endothelins, these are chemicals that are released from the damaged blood vessel wall. And so they stimulate smooth muscle constriction. Also, decreased temperature. You know, you go out in the cold and you start to turn pale because these peripheral blood vessels try to shunt the blood to the core of your body, away from the periphery. And that's why when people get frostbite, it's their ears, the end of their nose, their fingertips, their toes, because the blood has been shunted away from those areas. Okay, so that's local control at each capillary bed. Back to systemic control, nervous system. Back to my favorite part, the medulla oblongata. So right in this same area of the medulla oblongata, remember that we had the cardiac acceleratory center and the cardiac inhibitory center? You also have the vasomotor center. Now this works, this is a little interesting. You have to kind of hang with me on this. These centers have opposite effects depending on where the arterioles are. Okay? So just bear with me. There is, coming from this vasomotor center, there is a large group of neurons that when they send their signals out, it causes widespread vasoconstriction. At the same time this is going on, you have another set, a smaller group of neurons that basically produce vasodilation in skeletal muscles and the brain. And so if you think about the fight or flight reaction, we said that blood is shunted away from the periphery of the body. Why? Because those arterioles constrict. Blood is shunted away from the skin, away from your digestive tract, away from your urinary system. Now, if all of those arterioles constrict, that blood's got to go somewhere, right? Because what happens is that blood is shunted away or squeezed away from those areas and sent to the skeletal muscles and the brain. And so you've got two opposite things going on. You've got vasoconstriction of some arterioles and vasodilation of others, because you're trying to send the blood to these areas, away from the non-essential, or at least momentarily non-essential parts of the body. So this is what I mean by you got to figure out where am I in the body, what's happening. Because you can't say, oh, well, everything constricts. No, not everything. Where am I, what am I trying to do? So again, norepinephrine, that's released by any neuron that releases norepinephrine is called an adrenergic neuron. Remember that the neurons that release acetylcholine are called cholinergic. So this adrenergic just means the neurotransmitter norepinephrine is produced. And so that stimulates contraction or vasoconstriction. Contraction of the smooth muscles produces vasoconstriction in most of the arterial walls. The ones in the digestive system, urinary system, skin, liver, those kind of places. So these neurons are adrenergic neurons, this large group of neurons. The other ones, the small group of neurons, they release acetylcholine. They are cholinergic neurons. And what they do is they basically stimulate more nitric oxide production so that the arterioles that are here and here relax. Basically, these neurons, the cholinergic and the nitroxidergic, that's the small group of neurons that innervate basically these arterioles. The arterioles in the skeletal muscles and the arterioles that deliver blood to the brain. Okay. So you've got two groups of neurons. You've got a group of neurons, well, think about it. This is a large group of neurons because there's a whole bunch of freaking arterioles. Okay? And most of your arterioles are innervated by this group. And so they're going to constrict. Make sense?
Everywhere else.
Everywhere but here and here. Yeah, exactly. And so it just makes, this large group, a small group, because there's not as many arterioles in your skeletal muscles and brain together as everywhere else in your body. Okay. And so the point is, this causes constriction of everything except for these. These cause dilation. At the same time. So that blood is shunted away from the periphery to the critical areas. And this happens during the fight or flight response. Anything that increases sympathetic autonomic nervous activity causes this. And the difference is these neurons release norepinephrine. These neurons release either acetylcholine or nitric oxide. And so that's why you can have neurons coming from the same part of the brain going to different areas of the body having different effects, because they're releasing different neurotransmitters.